So this is exploring inverse functions, and what you're going to look at on here is it says Chandler and Isaac both like to ride bikes for exercise. They were discussing whether or not they have a similar pace so that they could plan a time to bike together. So Chandler said that she bikes about 12 miles per hour, meaning that she can go 12 miles in 60 minutes. Okay. Isaac looked confused and said he doesn't know how many miles he bikes in an hour because he calculates his pace differently. So he didn't know. So using Chandler's information, determine the x and the y variables. So what is the independent variable? That's the x, and what is the y? So there's two things that we need here. X is always the independent variable. It's the one that doesn't change. So independent means like it doesn't depend on something else, right? It's the one that actually makes the other one change. Y is called the dependent variable, and it actually depends on the x. So the way the y changes depends on whatever the x is. So there's two variables. Variables are the ways we describe things. What are the two things that are going on in the problem? Like, what two things do you need to know about the bikes, about them riding the bikes, to know how fast they're going? What two things do you need to know how fast they're going? Yeah. So you need to know the time and the distance. So you need to know how much time did they spend riding the bike and how far did they go. And then you can figure out how fast they went. So x is the time. Okay? So x is the time that they spent riding the bike. And that time is probably going to be in minutes, or you could put it in hours, whatever. But we're going to put it in minutes for right now. And then the dependent variable is the distance. So what that means is, and it should make sense, right? If you're a bike rider, like the more time you spend riding your bike, the further you go. That's kind of what this means. X is time, Y is distance. So the more time I spend riding, the longer I ride the bike, the farther I go on the bike. That's the distance. So Chandler uses time to determine the distance she travels. So figure out how far she will go in 1 minute. That's what we want to know. How about in 5 minutes? How about in 10 minutes? How about in 20 minutes? How about in 30 minutes? How about in 60 minutes? And then it says T minutes. So there's one that we already know, right? We know Chandler can bike 12 miles in 60 minutes. So we already know this distance is 12. Okay? Now, my question is, what did they have to do to get from 60 to 12? Like, how could they figure out how, if it takes 60 minutes to go 12 miles, what is that? What's the relationship there? Like, how could you get from 60 to 12? Mathematically.
12 times 5.
Yeah, 12 times 5 gives you 60. So 60 divided by 5 gives you 12. So what we're able to do is take these and divide by 5, and that's going to tell us how far they went. So in 60 minutes, if they go 12 miles, then in 30 minutes, how many miles can they go? 6. Yeah, divided by 5. So they can go 6 miles in 30 minutes. They can go 4 miles in 20 minutes. They can go 2 miles in 10 minutes. They can go 1 mile in 5 minutes. Then we get to 1 minute. If you take 1 minute and divide by 5, you get 1/5. So we can write it as a decimal. That would be 0.2. So in 1 mile, in 1 minute, they can go 0.2 miles. So that's how you're able to go through and see this. Okay, so you're able to see all those. So what we did. So you just told me in the earlier ones, how we got this number down here is we took the time and divided by 5. you take any of these numbers and divide by 5, that's what you get. So if you don't know what the time is, if you know the time, to get this, you just take the time, so t, and not my t is not good there. So you take the time and divide by 5. That's the formula that we use. Time divided by 5. And if you know that Chandler biked for 100 minutes, then you know that's 20 miles, because 100 divided by 5. So you can figure out how far she biked depending on the number of minutes or the time. Okay? So that is the first thing. Now, in question 3, it just wants us to write the equation. The equation is y equals the time divided by 5. So that's going to be our equation. And I'll go ahead and write that. But the equation is just y equals time divided by 5. We figured that out by looking at all of our numbers and seeing, well, all I got to do is divide by 5. So that is the answer as we go down to number 3. Let me erase this. So y equals time divided by 5. And then we're going to try to graph. Okay, so right here, write the equation for Chandler's pace using time in minutes and distance as a dependent variable. So it's y equals t over 5. Now, what is y? Y is your distance. So you could write it, sometimes you might see it written like this. Okay, the distance traveled equals time divided by 5. So they may write it like that. It's the same thing. It doesn't matter. So y is your distance, right? X is your time. So y equals the time divided by 5. So now we're going to make a graph of this. We're going to make what's called a scatter plot, basically. That's what we're going to do. So let's take our time to do this. So I'm going to erase this, and on the x-axis, we're going to have the time. So this is going to be time down here. And on the y, we're going to have distance. So time is going to go across, distance is going to go up and down. And on here, we want to know, this is going to be time in minutes. So I'm going to go by 5. Each line is going to count as 5. So this is going to be 0. The second one's 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100, 105, 110, 115, 120. It's a lot here. 130, 140. We'll stop right there. So every line going across is going by 5 seconds. 5 minutes. Then the distance in miles, I'm going to make each one go up by 2. Okay? So I'm just going to go 2, 4, 6, 8, 10, 12, 14, 16, all the way up. I think I get to 40. Oh, and that's it. So I've got time and I've got distance. So I've got how many minutes it takes, and I've got the distance that I've traveled. And what I want to do is plot or put those points that we have earlier onto, so those points in the table, I want to put those onto this graph. So the first one is the point 60, 12. Think about it, 60 minutes and 12 as your distance. So I'm going to go over to 60 minutes. I'm going to go up to 12, and I'm going to put a dot right there. So at 60 minutes, I can tell that I'm going 12 miles. The next one was at 30 minutes, I went 6 miles. So I go over to 30, go up to 6. At 20 minutes, I went 4 miles. At 10 minutes, I went 2 miles, right? At 5 minutes, I went 1 mile. That would be like right here. And then at 1 minute, I went 0.2 miles. That's got to be like right there. Very small. So I've got 6 different dots there, 6 different points. And what I want to do is make a line that goes through all of them. So if you think about it, you're going to make a straight line the best you can. It continues. Right? It will continue through all the points. It's probably not straight, but it's close enough. So that shows the relationship between the time and the distance. So as the time increases, the amount that you biked increases. So as I get all the way out here to 120, I can see she's biked almost 24 miles, right? So the longer she rides the bike, the longer she has traveled. That kind of makes sense. That's kind of like a common sense thing. We all see that, the longer you ride the bike, the longer you should travel, right? The farther you should be able to go. So that's the graph there for the distance and the time. So what we have to look at now is on the second page, we're going to end up having to make a second graph, which is going to take us a little bit more to try to finish this, but it's not going to be extremely hard. But we have to make a second graph. So the second one, let's scroll down, and I'm going to erase this one off the screen for you. But it says Isaac does things differently. So we talked all about Chandler and how Chandler figured out how far that she biked, right? Now we're going to talk about Isaac. So Isaac does things completely differently. So in this case, Isaac actually says, hey, I know I can bike a 5-minute mile. So he knows that he can go a mile in 5 minutes. He knows it. So for every 5 minutes he bikes, he knows he travels 1 mile. So how is this different than how Chandler describes her rate? So what does Chandler say in hers? So Chandler says that she can go what? What did she say at the very beginning? 12 miles in 60 minutes. Chandler says she can go 12 miles in 60 minutes, right? He says he can do actually a 5-minute mile. Okay, so that's how they've just said it differently. And we're going to figure out that basically they're saying the same thing. Okay? They're just saying it in a different way. So who goes at a faster pace? Well, if you think about it, 12 miles in 60 minutes. 60 divided by 12 equals 5 minutes per mile. Right? Which is the same as a 5-minute mile. So they are the same. They go the same pace. They really didn't realize it just talking about it. She said she was talking about how she bikes 60 minutes and goes 12 miles. He was saying I can do 5-minute mile. But really what they're doing is the same thing. If he does a 5-minute mile and keeps going, he's going to get 12 miles in that 60 minutes. Okay? So that's the key there is to figure out like, hey, they're going the same pace. There's no difference. All right. So, number 7, Isaac uses distance. So here's the difference. She said, hey, in 60 minutes, I go 12 miles. Isaac says, I can bike a 5-minute mile. So he uses distance to figure out how long he's been riding. She looks at her watch and says, "Oh, I've been going for 45 minutes," and she can figure out how far she's riding. He looks at his watch and like looks at the distance to figure out how long he's done it. So they do it backwards if you think about it that way. Like think about it, like she has a stopwatch. He has a stopwatch, or he has like a GPS thing, a counter. She has like a stopwatch. So that's the difference. So Isaac uses the distance to determine how long he's ridden. Determine how long it will take him to travel 1 mile. So if he in 1 mile, how much time does it take? Yeah, 5 minutes, right? So for 2 miles, it's going to take him 10 minutes. 4 miles, 20. 5 miles, what? 25. 6, 30. What about 12? 12 miles, 60. Okay? So what did you do? So now the question is, how did you get from here to here? How did you get from 12 to 60? How did you get from 6 to 30? How did you get from 5 to 25? You multiplied by 5. So you take the distance times 5. So the time is 5 times the distance. So that's your equation. Time is 5 times the distance. So y equals 5d. 5 times the distance. Notice it's the opposite of what we just said. So we said that the distance was the time divided by 5. So that means the time is the distance multiplied by 5. So it's the opposite. That's what inverse actually means. Is that these are the opposites of each other. So that is the first thing that inverse actually means in this problem. So now we get the privilege to do one more graph. Okay, it's the last one on here. But it says sketch a graph of Isaac's function. So on Isaac's, the distance, this top thing is going to be the x. So we're going to do the distance going across, and we're going to do the time going up. So it's going to be different than the other one. Okay, so I'm going to scroll down and erase this stuff. So going across, I'm going to actually go by 2 all the way until like 40. So I'm just going to go by 2s all the way across. So let me get rid of this. And I'm just going to go by 2. Every line counts as 2. So this is 2. So that's 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. I know it's a lot of writing. I only got to do it one time. 40. And this is this is on the x-axis, right? So this going to 40, this is his distance in miles. So this is the distance that he's traveled. And then the time is actually up here. The time is going to be the vertical axis. So for time, we're going to kind of do the same thing that we did earlier. We'll just go up by 5s. We'll go to 100. So we'll go by 5. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95. Now we're at 100. So we've got the distance and the time. Okay, so we're going to fill in our points here. All right, so the points that are in the table. So we're going to do 6, 30, and then we're going to kind of work our way back. So go over to 6, up to 30. That's 1. Okay, 4, 20. Then we did for 4 miles in 20 minutes. Then the next one that we did was 2 miles, or I forgot the 5, right? 5 was 25. Then we did 2 in 10 minutes. We did 1 in 5 minutes. And then that in 1 mile we did 0.2. That was that little one. So we've got this line. And notice if we keep it going, looks like that. Okay. That's our line for distance and time. All right? Everybody good so far? Okay? Okay. So, here's an issue. This is a big difference here. So, let's look at, we want to look at the bottom. We're going to notice something about inverses. This is where the problem that you just did, this is where we're supposed to have like our big moment where we actually take this problem and learn something that's going to help us answer some questions later. Okay? So, this says, you may have noticed that Isaac and Chandler actually bike at the same pace. They really do, right? Which means that their functions would be exactly the same if we hadn't just switched the x and y. So all we did was switch the distance and time, right, on the two graphs. So the independent and dependent variables, the x and y. When this happens, functions are inverse functions of each other. That means they're the opposite of each other. They're the inverse of each other. Okay? When this happens, the original function is written as f of x, that's y equals, and the new function is written with that little -1. If you see that little -1 sign, that means it's the inverse. Okay? So, using the equations, tables, and graphs, make a list of observations of what happens when you have two functions that are inverses of each other. So look at the table from Chandler, the table of numbers. Look at the table for Chandler's. Go back to page 1 and look at it. And then look at the table for Isaac, right beside it. Okay? What do you notice? So in the table for Chandler and the table for Isaac, what do you notice about the numbers? They're flipped. Okay? So what happens in an inverse, this is the first observation. What happens in an inverse function? You switch x and y. So you see that that's all that happened from Chandler to Isaac is we just switched x and y. All you do is flip it. Nothing else happened. Just switched x and y. The end. Okay? Now, something else you should notice about, look at the equation of them. One of their equations is y equals, it was, what? T divided by 5, right? Or we could say 1/5 of t, 1/5 of the time, or t over 5. The other equation was y equals 5 times the distance, right? So in this equation, remember our slope comes in front of that letter. So in this equation, what is our slope? This first one. 1/5, right? In this equation, what is our slope? 5. So what's that? So what's the connection there? the slope is, and the word is called the reciprocal. So it's a different word, but the slope is the reciprocal of each other. So what that means is, there's an example right there. But what that means is that, for example, let's say we have a slope of 10, then the other one would be 1/10, right? That would be an example. If we have a slope of 5, then the other one's 1/5. So it's just putting it on the bottom of the fraction. So it's the reciprocal. So if you knew, like if we actually knew earlier that it was time over 5, then we would actually know the distance would be 5 times that. Like it's, if you're dividing in one, you're multiplying in the other. So you just switch it. So if we get an equation and we know it's like y equals 10x, then we know the other one is y equals 1 over 10x. Like it just flips it, the slope. Okay? Now, the last thing says, why do you think, so again, this is just kind of a question, so why do you think inverse functions have these characteristics? Okay? And so what is the, and the reason that we're talking about this is because they are showing the same thing, okay? Just switching the way they write it. So it's the same as Chandler and Isaac. They go the same pace. They both go 5 miles an hour, or 12 miles an hour. They go 5 miles. They were able to go 1 mile in 5 minutes. They both go 12 miles an hour. But Chandler writes it differently than Isaac writes it. So we just switch the x and y. So they both of those graphs actually show us the same thing. They show us that in an hour they can go 12 miles. But they show it to us in a different way. And that's the inverse. So when we take an equation and we want to find the inverse, we have to switch x and y and then solve for y. That's our 2 steps. To do an inverse, it's a 2-step process. Step 1 is switch x and y, and then step 2 is solve for y. That's the process for finding